We are going to solve another application by using definite integration to find areas under curves. Remember that the rule is integral for y dx starting from x equals a to x equals b. When we want to find the area between the curve, the x-axis, and the lines x equals a and x equals b. Look at this example. Given that the region R is enclosed by the curve with the equation y equals x squared plus 4 over x squared where x is greater than 0, the x-axis and the lines x equals 1 and x equals 3. So we have the curve, the x-axis, and the lines x equals 1 and x equals 3. Find the area of R. This example is different than the one we solved previously. Here, we know the limits of x, so no need to do a sketch. That is why we directly write area is integral of y dx, knowing that x starts at 1 and ends at 3. So integral y is x squared plus 4 over x squared dx, where x starts at 1 and ends at 3. Before we integrate, we need to adjust the form of the fraction. We say it is from 1 to 3, x squared plus 4. We will raise the x, so x to the power minus 2 dx. Now we can integrate. We put everything between square brackets, and here we have the limits. X squared is x to the power 3 over 3. We simply add to the exponent and divide by the exponent. Plus 4 multiplied by x to the power minus 2 plus 1, which is minus 1, over minus 2 plus 1, which is minus 1. Always try to organize the function as much as possible before substituting with the limits. So, x to the power 3 over 3 plus 4 divided by minus 1, which is minus 4. X to the power minus 1 is the same as 4 over x to the power 1. Just by changing from the numerator to the denominator, you must change the sign of the exponent, and the limits are from 1 to 3. Now we substitute the limits. For x equals 3, 3 to the power 3 over 3 minus 4 over 3 to the power 1 minus. Now for the lower limit, which is 1. 1 to the power 3 over 3 minus 4 over 1 to the power 1 equals 3 to the power 3 divided by 3 is 3 squared. We simply are working with the powers. 3 squared is 9 minus 4 over 3 minus 1 to the power 3 is 1 over 3 minus 4. We solve each parenthesis separately. For the first one, the common denominator is 3. We have 27 minus 4 minus, here also the common denominator is 3, 1 minus 12. 27 minus 4 is 23 over 3 minus 11 over 3. Both are over 3, so 23 minus times minus 11 is plus 11. So 23 plus 11 over 3, it is 34 over 3 or 11 1 over 3. This is the area for region R enclosed by this curve, the x-axis, and x equals 1 and x equals 3. As you can see, this was very simple. We simply substituted inside the formula of the definite integration, and then we calculated normally. You can solve all of these exercises in the same way. As you can see, in each part, the form of the function is changing and the limits are changing. All you need to do is to substitute inside the formula of the area. Then you calculate the definite integration, which represents the area. You can also solve this exercise. The diagram shows a sketch of the curve with the equation y equals 3x plus 6 over x squared minus 5, where x is greater than 0. The region R is bounded by the curve, the x-axis, and the lines x equals 1 and x equals 3. Find the area of R. Here you define the area as a definite integration, and you calculate the numerical value of the area.